Start recording. Okay, so from the previous one, okay, this is a technique, okay, by substitution that you're supposed to learn. Okay, so remember, come to section F here, integration techniques. Okay, we have three techniques that you're supposed to know. When we entered these three techniques, we already expected students to know how to do for the previous A, B, C, D, E. Okay, the second technique that you need to know is by parts. Okay, the second technique that you need to know now is by parts. So what exactly is by parts here? That will be rule number 34. 34, okay, by parts. So what actually happened is your integration, you have two parts. So one is u, one is v prime. Okay, one is u, one is v prime. So this u and v prime can be in any form, inverse trigo, trigo, log, exponential, polynomial. It can be any form. Okay. So by part say, when you want to separate them, okay, when you want to solve this, we actually can rewrite them in this form. So u times v minus v prime, u prime v. Okay, but since this u and v prime can be in any form, okay, ln polytrigo e inverse trigo, how should we actually choose what to do? Okay, so we actually have a process of the order. Okay, so how to choose ux? So we follow this order. Okay, will be inverse trigo. Okay, ln polynomial, trigonometry, exponential. Will follow this order. So in other words, it means that the priority go for the first one. So if you have a ln and polynomial appear, so the priority would go for the ln as a u. Okay. So now let me explain to you how to actually do this question. Use this, apply this formula. Okay. Example 1. Okay, so this one is one time by parts. Okay, this example is one time by parts. Let's see. So I have maybe this one xex. Okay, xex. So you can see there's a component of polynomial and exponential according to the order. So I will choose my u as x, my v prime as ex. Okay, so differentiate, I have 1. Okay, integrate, I have ex. So I need to use these two components. So I write them accordingly, u and a v, so I have x ex minus integrate of u prime and v will have ex dx. So in the end, it's x ex minus ex plus c. So you will see that this one is a one time by parts. Okay, another questions. Let's say two times by parts. Okay, so let's say I have a question for x squared sine x. Okay, x squared sine x. According to the order, okay, on how to choose u. Okay, so u will go for x squared, v prime will go to sine x. So u prime will go to 2x. Okay, v equals to negative cos x because of integrate. So this is the first time. Then I will get u and v together. Negative x squared cos x minus minus become plus of 2x cos x dx. You will see that I need to do another round because this is another by parts. Okay, this one is another by parts, so therefore I need to do another round. So my u is 2x, my v prime is cos x, my u prime is 2, my v is sine x. So with these two together, so I have a negative x squared cos x plus, so u and v, so I have a 2x sine x minus 2 and sine, 2 sine x dx. So I will have a negative x squared cos x plus 2x sine x, okay, minus 2, this one become plus cos x plus c. That's your final answer. So this is a 2 times by parts. So from this demonstration here, you will see that if I can do 1 time, if I can do 2 times, okay, definitely can be 3 times, 4 times, and so on. But what if there is infinitely many times? Let's see. Okay, so this one is a loop. It's a loop question. Okay. So let's say I have an integrate of ex sine x. Okay. So according to the order on how to choose u, ln polytrigo e. Okay. So I have a u equals to sine x. My v prime equals to ex. My u prime equals to cos x. My v equals to ex here. So I can do this. So what I get is u and v, so ex sine x, okay, minus integrate of ex cos x plus dx. Okay, that means over here, of course, you will see another time, we need to do another time by parts. So we just do it first. So u equals to cos x, v prime equals to ex. So u prime now equals negative sine x. So v equals to ex. So you do it another time. Let's see what happened. So ex sine x minus this one over here. I have a u and v, so I have ex cos x. Okay, minus become plus. So ex sine x. Let's see what do we get. Ex sine x minus ex cos x minus integrate of ex sine x again. You'll see there is a loop. Okay, it go back to the same thing. But one thing good about this loop is this and this, they are the same. Therefore, I can combine them together to join them together. By shift it over, become plus 2 times of it equals to ex of sine x minus cos x. Okay, bring the 2 over, ex sine x dx equals to 1 over 2 ex sine x minus cos x plus c. Now you can actually put the plus c over here because you already completed with the integration. Okay. Another thing that you need to aware is this part here, sine x minus cos x. Sometimes the question asks you to write in the r and alpha form. So sine x plus cos x, 1 here, there's a square root 2. There is a sine of x minus pi over 4. Okay, plus c. So you can see that it can be written in this form if they want to. Okay, a question may be asked you to change like this. So this one is the integration by parts. Okay. Then after that, there will be some special formulas, as I say. So 25, 26, 27, 28. So let's see how to actually get these answers, okay, for the proving. So 25 here. 25 here, integrate of sine square x. So of course, this one can be done by using trigo. Okay, if since you already learned about how to actually use the trigo rules, we can change power 2 to power 1 by using trigo formulas. Okay, but right now, the objective is to look at it from by parts. Okay, what happens if I do it by parts? So I will do it by sine x times by sine x dx. Okay, so I have my u equals to sine x, and my b prime equals to sine x. So I differentiate, I have a cos x, I integrate, I have negative cos x. These two put together. Okay, so I have a negative of sine x cos x. Okay, negative of sine x cos x. So over here, negative, so become plus of cos square x. Okay, So what actually happened next is cos square looks like we need to do another by parts, isn't it? Okay, we don't really need to. What we can do is this cos square x, we can change it into identity of 1 minus sine square. Separate them. Negative sine x cos x minus integrate plus integrate of 1 dx minus of integrate of sine square x. So you will see that minus, okay, this is plus, is just like what the loop that we have earlier, is 2 times. 2 times of the sine square x. This one become integrate of 1 become x, so x minus sine x cos x. So you will get an integrate of sine square x dx equals to 1 over 2 of x minus sine x cos x plus c. Okay, this will be 25. 26 run exactly the same thing. 26 of integrate of cos square x. By doing the same procedure, you will get 1 over 2 x plus sine x cos x plus c. Okay, now comes to 27. 27 integrate of arctangent x. Back to our section B, okay, you will see that I can integrate of 1 over 1 plus x squared go back to arctangent, but I don't know what exactly is in the integrate of arctangent x. Okay, over here, according to by parts, okay, we will choose u equals to arctangent. Okay, v prime equals to 1. Okay, we read as 1 times arctangent x. So your u prime here, it will be 1 over 1 plus x squared. You'll be expected to remember the differentiation. And your v here become x, and this combine together. So what we get is u and v. So x arctangent x minus integrate of x over 1 plus x squared dx. So x arctangent x, of course, just like that. Okay. The what interesting is the one at the back. This is actually rule 23. Okay, the long rule. So by manipulating the value, so I have a 1 over 2 and a 2 here. Okay, x with 1 plus x squared. Okay, and by manipulating the 2 and the half here, you will see that the top become the differentiate of the bottom now. Since fulfill the differentiate the top as about the differentiate of the bottom, it fulfill the long formula. Therefore, I have x arctangent x minus 1 over 2 of ln 1 plus x squared plus c. Okay. Then 28. Another special one is ln x. Okay. Similarly, the ln x we will read as u equals to ln x. V prime equals to 1. U prime equals to 1 over x. V equals to x. So use this 2. Okay, what I get is, okay, u and v, so x ln x. So minus of u prime v, 1 over x times x dx. So x ln x, of course, just as it is. 1 over x times x is 1. Integrate of 1. Integrate of 1 back to x minus x plus c. Okay, so with this, you actually see that, okay, we discuss about special formula 25, 26, 27, 28, 29, 30, 31, 32 is from yesterday. Okay, then the integration technique 33 and 34. So we have one more technique to go. Okay, leave it for the next lessons. Okay, let me put down the questions. Let me put down the questions. Okay, so these will be your exercises for by parts. Okay, further math students, you are reminded that you need to learn these techniques properly. Okay, because when it comes to your further maths, you have further questions to do. You will be expected to know how to apply all of these rules. Okay, that's all for today. Thank you very much.